Hello students, in the previous video we have seen how to solve numericals based on first rule for differentiation under integral sign, that is Leibniz rule first. There we have seen that the limits of integration, they are constants. Now in this video we will study the second rule. Now in this case what we have is, if the given integral, that is I alpha, alpha is the parameter, it is integral, the lower limit is A alpha and upper limit is B alpha of some function of alpha and x dx, where alpha is the parameter and x is the variable. Now in this case you will see the limits of integration, they are functions of the parameter alpha, whereas in the previous one we had the limits as constants. So when we have such case, that is the limits, they are the functions of the parameter, then how the rule is applicable, we will see that. This is I alpha, that is the given integral. So di by d alpha, that is we are differentiating the given integral with respect to the parameter alpha. It is equal to integral A alpha to B alpha. These are the limits. We have dabba by dabba alpha, that is the differentiation sign, when it are taken inside the integral sign, it turns into a partial derivative. So we are differentiating partially with respect to the parameter alpha. F of, that is a function of some parameter alpha and x dx, plus f of b alpha into d by d alpha of b, minus f of a alpha into dA by d alpha. That means we'll see that it is equal to integral from a alpha to b alpha. This term is partial derivative with respect to alpha of the given function into dx, plus value of the function, the given function, that is this f alpha x, value of that function at upper limit b, that is instead of x we have to substitute the upper limit into derivative of the upper limit b with respect to alpha, that is we have to differentiate the upper limit with respect to the parameter alpha, minus value of function at lower limit a, that is we have to substitute for x as the lower limit. So that is value of function at lower limit a into derivative of lower limit with a with respect to alpha, that is the lower limit we have to differentiate it with respect to the parameter alpha. Okay, we'll see this with the help of some numericals. If f of x is equal to integral 0 to x minus t bracket square into some function g of t dt is given, then you have to prove that d cube f upon dx cube is equal to 2 times g of x. Now we'll solve this numerical. What is given is f of x is integral 0 to x minus t bracket square into g of t dt. Now in this case we can see t, it is the variable and x is the parameter. So we'll apply the second rule, and as per this rule df by dx, because x is the parameter, it is equal to d by dx of the given integral. It is equal to, now applying the rule, it is equal to how much? Integral 0 to x dabba by dabba x. X is the parameter of this function, that is x minus t whole square into g of t dt, plus what we have the second term, value of this function for the upper limit. The upper limit is x. So what we'll do, we'll substitute for t as x, that is the upper limit. So what we have is x minus x whole square into g of x into, we have to differentiate the upper limit with respect to the parameter that is x. The parameter is x. So we have d by dx of the upper limit x minus, the second term is what? Value of the function at lower limit. So it will be how much? X minus 0 whole square, because the lower limit is 0. So instead of t, we will substitute 0. So we have x minus 0 whole square g of 0 into, now we have to differentiate the lower limit with respect to the parameter x, that is d by dx of 0. So what we will have is, now this term, it's dabba by dabba x of x minus t whole square g of t dt. This g of t is constant and derivative of this term with respect to x will be how much? It is 2 times x minus t. This term is constant, it will remain as it is. Now in this case we have x minus x whole square, so this is 0, so this term is 0. And here what we have? We have d by dx of 0, that is 0, this term will also be 0. So what we have is integral 0 to x 2 times x minus t g of t dt plus 0 minus 0, that is integral 0 to x 2 times x minus t g of t dt. But this was what? df by dx. We'll apply the rule again, that is we want now d2f upon dx square. It will be how much? Integral 0 to x. Apply the rule again to this. Dabba by dabba x of this 2 times x minus t g of t dt plus this function for the upper limit, that is 2 into x minus x, for t will substitute x g of x into, we are differentiating the upper limit with respect to the parameter. The parameter is x, so we have d by dx of x minus value of the function at lower limit, that is 2 times x minus 0 into g of 0, and then we'll differentiate the lower limit with respect to the parameter x. So it is d by dx of 0. So what we have is integral 0 to x d dabba by dabba x of this. So what we'll have, it is only 2, g of t is constant, into dt plus this term, it will be 0 because we have x minus x, and here also it will be 0, d by dx of 0. So this is 0. So what we have is integral 0 to x 2 times g of t dt. This is what? d2f upon dx square. Now we'll apply the rule once again, so that what we'll have is d cube f upon dx cube, which we have to find. So applying the rule again, d cube f upon dx square is integral 0 to x dabba by dabba x of this function, that is 2 times g of t dt plus the value of this function for the upper limit x. So it will be 2 times g of x into, we have to differentiate the upper limit with respect to the parameter, that is d by dx of x minus value of this function at the lower limit, that is minus 2 times g of 0 into differentiate the lower limit, that is 0 with respect to the parameter x, that is d by dx of 0. So what we have is, now this is dabba by dabba x of 2 times g of t. This g of t here, it will be as good as constant, so this will be 0. Here it will be 2 times g of x, d by dx of x is 1. So we have 2 times g of x, and here it is 0. So what we have is 2 times g of x, that is d cube f upon dx cube is equal to 2 times g of x, that has been asked. D cube f upon dx cube is equal to 2 times g of x. Now we'll see yet another numerical. it's given if phi of a, that is equal to integral from a to a square sine of ax upon x dx. You have to find d phi by dA using this second rule. Okay, this is the given integral. Phi of a is integral a to a square sine of ax upon x dx. You can see here the limits of integration. They are the functions of the parameter, because in this integral x is the variable with respect to which we are integrating and a is the parameter. The limits are the functions of the parameter. Okay, we'll apply the rule. Now second, as per the rule, d phi by dA is equal to d by dA of the integral a to a square sine of ax upon x dx. It will be how much? Integral a to a square. This sign, when taken inside the integral sign, it will be dabba by dabba a of sine of ax upon x dx, plus we are differentiating the upper limit with respect to parameter a, that is d by dA of a square into value of this function for the upper limit, that is sine a of, for x we are substituting the upper limit, it is sine a into a square upon, for x also we'll substitute a square. Okay, minus value of the function for the lower limit, so it will be sine a into a. For x we are substituting a, and this x also it will be a, into we are differentiating the lower limit with respect to the parameter a, that is d by dA of a. What we have is integral a to a square dabba by dabba a, that is partial derivative of this term with respect to a. It will be for sine ax, it will be cos of ax, this x as it is, and derivative of the term ax with respect to a is x dx, plus d by dA of a square, it will be plus 2a into sine of a into a square, that is sine of a cube upon a square, minus sine of a square upon a, because derivative of a with respect to a is 1. This now this x and this x will get cancelled, so what we have is integral a to a square cos of ax dx, plus this a and a square, this a will get cancelled with this square, so what we have is 2 upon a sine of a cube minus 1 upon a sine of a square. Now integral cos of ax is sine of ax upon a. The limits are from a to a square, plus these two terms as it is. So this will be sine of a into this a square, that is sine of a cube upon a, minus sine of a into this a, that is sine of a square upon a, plus this 2 upon a sine of a cube minus 1 upon a sine of a square. So what we have here is the sine of a cube upon a plus 2 times sine of a cube upon a, we have 3 upon a sine of a cube, and this minus 1 upon a sine of a square minus 1 upon a sine a square. These two terms together will have minus 2 upon a sine of a square, and this is the value of d phi by dA. Hope you have understood this concept. In the next video we'll solve some more numericals. Thank you.